Okay, we're going to start looking at some properties that are carryover from algebra. Okay, an addition property says if you have two equal things and you add the same amount to them, they maintain their equality. If A is equal to B, then A plus C is equal to B plus C. Subtraction property effectively says the same thing, only if you start out with equals and subtract the same amount, you end up with equals. Multiplication property, start out with equals, multiply both by the same quantity, you maintain the balance, the equality. Division property, start out with equals, okay, divide both sides by some number as long as you're not dividing by zero, and you maintain the equality, okay. The distributive property, which you should know well from algebra, as stated here, A times the quantity B plus C is AB times AC. Example, 3 times the quantity 2x plus 5 is 3 times 2x, 6x, plus 3 times 5, 15. We have a reflexive property which says anything is equal to itself. We have a symmetric property says if A is equal to B, then B is equal to A. We have a transitive property which says if A is equal to B and B is equal to C, then A is equal to C. Okay? And we have a substitution property which we'll see examples of with some of the outline proofs that we're going to show in this video. Okay? So here we go, a familiar problem, okay? And what we're going to do is do a formal discussion of proofs, okay? We've done this problem. Okay, this problem involves, involves the angle addition. You've done problems exactly like this. With a proof in geometry, what we have to do is we have to account for every step along the way. Okay, so it's not doing anything that we hadn't done before. It's just that we have to account for every step along the way, and we have to support that with one of the reasons. And most likely the reasons are going to come from this list right here, okay, or an additional list which includes some postulates or ideas from geometry definitions that we've already cited. Okay, so let's go forth with it. Okay, all right. The first thing we note is that we have an angle addition problem. Okay, that is the angle ADB plus BDC is going to equal the all-inclusive angle ADC. So we write that down right here. The measure of ABD, well, it should actually be the measure of ADB, excuse me, and angle BDC add to angle ADC. Where does that come from? Angle addition, okay? Next, okay, we were told in algebra what those angles were. So we're going to plug those in. What do we do effectively? We're replacing ADB with x, BDC with 2x plus 10, and ADC with 139. So we've substituted our values from algebra into the geometric statement, substitution property. Okay? Obviously, 2x and 1x can come together to 3x. What are you doing there? You're simplifying. That's simplifying. It's just a process of solving the equation, okay? It's just simplifying, okay? What do we do now? Solve for x, we got to subtract 10 from both sides, which would give us 3x equals 129. What accounts for that? Subtraction property, okay? What do you do next? You divide by 3. You divide both sides by 3, resulting in the answer. What accounts for that? Division property. You started out with equals, you divided both sides by 3, so you still have equals. Okay? Let's look at another one. Okay? In this problem, we're given that, okay, BD, the ray BD, is bisecting angle ADC. What does that mean? It's creating two equal angles. Okay? All right? So, really, in a formal proof, we want to account for everything that's given. So what we're going to do is we're going to write down that DB is bisecting ADC. Now, where did you get that? That information was given to you. So that's exactly what you're going to say is it was given to you. But what do you know is true because of that? Well, you know that since the BD is bisecting it, it's creating two equal angles. What are the two equal angles? ADC and BDC. So they are equal. How do we know that? Because that's the definition of a bisected angle. A bisected angle is forming two equal angles. So we will write the definition of the angle bisector. Now, what are you going to put in next? You're going to put these algebra values in. What did you do? You substituted them back in. Now we have an algebraic equation. How do we solve this algebraic equation? We have to collect the like terms. We have to subtract 2x from the left side as well as the right side. So what do? You accounted for that by subtraction property. Now, next, what do you have to do? You have to divide. You have to divide by 2. You have to divide both sides by 2. What accounts for that? Division property. We're not finished because the problem did not ask us to find the value of x. It asked us to find the value of each angle. So we were told that angle ADB is 2x plus 40. It's implied in the picture. Where did the information come from? It was given to you. What do you know now? You know that x is 20. So what does that mean? You can plug 20 back in here. What are we doing then? Okay, 20 times 2 is 40 plus another 40 is 80. What did you do? You substituted your value of x back in there. Okay, substitution property. What comes next? Well, they've said find each angle. So we have to find the other angle. How do we know BDC is 80 as well? It's because the definition of an angle bisector, two equal angles, okay? So that is a more formal proof, okay? Ones that you're going to see initially are in all likelihood going to provide you with all of the statements, and you're going to have to account for the reasons, okay? And the reasons will largely be from that list given on the first slide, or from some properties of geometry that we will see and build on as we go through the course, okay? So that is pretty much it. This is, again, reflexive property, symmetric property, and transitive property. Just stated in another way. Reflexive, anything equals itself. Symmetric, if angle A equals B, then angle B equals A. Transitive, if angle A equals angle B equals angle C, then angle A is equal to angle C. Okay? So what you need to do is look at and outline section 2.4, okay? And then you need to look at the exercises at the end of 2.4, and that's what we'll be working on in class tomorrow, okay?